Welcome to our Day 4-7 screencast, where we will be studying one variable quantitative data.
This will begin our study of summary statistics with one variable to help us understand the data. What is statistics? It's the collection, the organization, the analysis, and interpretation of data. Today we're going to talk about how, after it's collected, we can begin organizing it. Here are some areas where you would use statistics. The data we're going to use for our mini lesson is 7 students and their Instagram followers.
We'll be looking at the centers. The 3 centers that we're going to study are mean and median and mode. But today we're just going to look at mean and median.
You can find these definitions in your notes as we go along.
The mean is the average. How we find the average is we add up all our numbers and divide the total by the number of data points. It is important to think about the mean as the fair share or the balance point. So let's find the mean of this data set. The first thing we got to do is add up all the numbers. We'll get 1,589. Now we got to divide by the total numbers. There are 7 numbers, so we'll divide 1,589 by 7 and get 227. Now let's think about the median. The median is the middle number. It's really important to put the data in order first. So we put the data in order from smallest to largest, and then we count the numbers to find the middle one. If you have an even number, we're going to divide by the average of the two, and use that as our median. So the first thing we got to do here is we got to put the numbers in order from least to greatest. 150, 177, 223, 225, 241, 273, and 300. So now we got to find the middle number. We do this by counting to find the middle. Here our median is 225. Now we're going to think about the spread. So there's 3 different types of spread that we're going to study during this unit. The 3 types of spread are range, interquartile range, and mean absolute deviation.
You may be familiar with range. Interquartile range and mean absolute deviation are going to be new to us today.
So range is the distance between the largest and the smallest data points. It lets us know how spread out the data is. We find this by using the highest number and subtracting the lowest number.
Notice here our range is going to be 6, the number 6, after you subtract. Back in Unit 3, we used range in a slightly different way, so don't get these two things confused.
So let's find the range of this data set. The highest number is 300, and the lowest number is 150. So we subtract 150 from 300 and we get 150. This is our range.
It lets us know how spread out it is from the smallest to the largest.
So there's a way to organize our data into a 5-number summary. Our minimum or lower extreme is the smallest data point. Our lower quartile is going to be the median of the lower half of data. We know the median, we saw that before. The upper quartile is the median of the upper half of the data. And the maximum is the upper extreme, or the largest number. So let's try to find the minimum of this. We've already found that using the range, so that was 150. Now let's look at the maximum. The maximum is going to be 300. We found the median to be 225. So now we're going to look at the lower set and determine the middle number between this set. So this is going to be 177. Remember, when we're finding the median, that we got to put our numbers in order. Again, for the upper quartile range, we're going to have our numbers in order, and we're going to find the middle number of the upper half. This is going to be 273.
Our 5-number summary is going to come into play during the next lesson when we make our box and whisker plots.
So now let's think about the interquartile range. It's kind of like range, but it's the distance between the upper and the lower quartiles. It's the middle 50% of the data. We find this by subtracting Q1 from Q3. So we found Q3 earlier to be 273 when we found the median of the upper set. We found Q1 to be 177 when we found the median of the lower set. We subtract this and find the range between the two numbers, and we get 96.
So this is how spread out the middle 50% of our data is. All right, now let's take a look at an outlier. Most of you are familiar with the fact that an outlier is a data point that doesn't fit in with the rest. But today we're going to talk about how we can prove it. Okay, so our formulas here to find our lower fence, as you can see, is Q1 minus 1.5 times the IQR. The upper fence is going to be Q3 plus 1.5 times the IQR. If a data point is outside these fences, it's going to be considered an outlier. Let's look at an example to help us understand these formulas. So we first found our IQR, and if you remember from the previous slide, our IQR was 96. We take 96 and we multiply that times 1.5, and we get 144. So now to find the lower fence, we're going to take that number 144 and subtract it from our quartile 1. If you remember, quartile 1 was 177, so 177 minus 144 gives us 33. So that's going to be our lower fence. So what you want to look at is over at the smallest data point. Is it below 33? No, it's not. So 150 is not going to be an outlier. So any points less than 33 would be outliers, so we can say no. Now let's find the upper fence. Now we're going to take quartile 3, which we found before to be 273, and we're going to add that number 144 we got when multiplying the IQR times 1.5. When we do that, we get 417. So we want to ask ourselves, are there any data points greater than 417? No, our highest point is 300. So we don't have any outliers in our data set. All right, last let's take the mean absolute deviation. Don't be overwhelmed by how complicated the directions look. We're going to take you through step by step. So basically, the mean absolute deviation is the average distance that each data point is away from the mean. So if you think about it, it's kind of like the mean of the means. We're going to look at that. All right, so the first thing that I like to do is I actually write all of my data points in a vertical column. Okay, and so we're going to figure out how far each of those points is from the mean. So I'm going to take each point and I'm going to subtract 227. Okay, so you can see that we have written each data point subtracting 227. The first difference, 150 minus 227, is negative 77. Our next difference is going to be negative 50. We continue this process until we have subtracted all of the data points. Now, if we added all of those numbers, we would actually get 0, which is not very helpful. So the next step that we're going to do is take the absolute value. So if you remember, the definition or the name of this is the mean absolute deviation. So I think about it as we took the mean, we calculated the differences between the mean and each data point, and now we're taking the absolute value of each of those. Now, after we take the absolute value of those, they're all going to be positive. So now we're going to add up all of those differences and then take the mean of those. So when we added up all of those positive values, we got 269. We're dividing that by 7 because that was how many data points we have, and so we get 38.43. So our mean absolute deviation is 38.43. All right, so that's been a lot of information. So now what we want you to do is go ahead and try calculating all of these things on your own. You have a blue or pink sheet for your work period. And here are the answers so that you can check. Remember, it's important to check our work when we try so that we know if we have any misconceptions. Good luck on your homework, and thanks for listening.